Hello, this is differentiation formulas. In this section, we will learn how to differentiate a constant function, power function, polynomials, and eventually product of all of these functions and the quotient of all of these functions. That's what we did so far. We did compute the derivative in the previous sections directly from the definition of the derivative of the function, which we remember definition of the derivative was the limit, and the computation was a little bit time consuming. That means, fortunately, based on this process, we discovered a few patterns and a few rules have been developed based on that. That means now, without using directly a definition, we can use some shortcuts, some formulas. That means, let's see. The first one will be a constant function. And if this will be my live session, I will probably ask you, what is the derivative of the constant function? And hopefully everybody will answer that it's 0. And why is 0? I really would like to hear the answer like that, because constant function is represented by the horizontal line, and the horizontal line has a slope 0. Slope of the line is the derivative of the function. Okay, that's what we can see. That's what I would like you to know. Slope of the horizontal line, constant function, is 0, and that's the derivative. Of course, I can use directly a definition, f of x plus h minus f of x over h, as h goes to 0. The value is always c, value is always constant, then 0 will give me, and this is tiny number, that means we will definitely get 0. That means the first formula, the first rule for today is derivative with respect to x of the constant function is 0. But always please think about the geometrical explanation. Okay, now the next function, the next rule will be for the power function. We do have a function x to the power of n, and at the moment, let's say that n is a positive integers. That means natural numbers. 1, 2, 3, 4, 5, and so on. That's what we know. The first function could be x to the power of 1. And again, I might ask you, what is the derivative of x, function x? And again, I would like to hear the answer that the derivative is 1 because slope of this function is 1. Right? That's mean, please think this way. Now, we do have function x squared. For this one, I can't really ask you what is the derivative, because we know how function x squared looks like. It's the parabola, and it's definitely changing the slope of the curve or the slope of the tangent for every single x in the domain. It's changing. That means we will have a formula. But we did, in the previous sections, we used the definition of the derivative, and we got 2x. I believe we also did x cubed. Derivative of x cubed is 3x squared. And now I think we didn't do x to the power of 4, but based on these values, based on these functions, I hope we can see the pattern. That means if x is taken to the power of 1, derivative is 1, and I can write maybe x to the power of 0. Of course it's 1, but I would like to see the pattern of the formula. Now, if we do have x to the power of 2, the 2 becomes a coefficient, and the exponent is 1 less. X to the power of 3, 3, and the x to the power of 2, 2 is 1 less than 3. That means x to the power of 4 will give me 4x cubed, which my point is, to get the formula for x to the power of n will be n, I can write it down, n, because the exponent becomes a coefficient, and the original exponent, it's 1 less. Okay? That means this is a power rule. In order to differentiate x to the power of n, derivative with respect to x of x to the power of n, it's n, x to the power of n minus 1. And most of the calculus textbooks, including our textbook, is proving that n could be any real number, which we know that power function the typical power function only consider the x to the power of n when n is the positive integer. That means if n is like -1 or -2, then theoretically we have rational function. But we can always think as a power form, x to the power of n. That means please remember n could be any number, rational, irrational, and we can always apply the power rule. Okay, that means let's see. I have example number 1. Find the derivative of the following function. F of x is equal to cube root of x squared, and state the domain of the function and its derivative. That means first of all, I see root function, but I just said that we can rewrite this as a power form. X to the power of 2 over 3. Denominator in the exponent is telling me what root we have to take, which we took cube root. Okay, and now I can follow my rule. The exponent will become a coefficient, and the coefficient, I mean the exponent, the original exponent, we have to subtract 1 to get the derivative. That means this is n, okay, this is n of course, and this number is n minus 1, which is 2/3 minus 1. 2/3 times x to the power of -1/3. The only thing is, if we got a negative exponent, we should rewrite without the negative. That means x to the power of negative number means that everything is placed in the denominator and we will still hold the original number 1/3. That means 1/3 means cube root of x, but we have to place in the denominator. That means that's the derivative of the function cube root of x squared. Domain of the function is simply all of the numbers. That's the domain of the function. Domain for the derivative is actually all of the numbers, but we have to subtract 0. Or you can simply say x is not 0. I'm just using a little bit of set notation. Because x is placed in the denominator, we can't accept 0. We're not dividing by 0. Okay. Another rule is constant multiple rule. If c is a constant f and function f is the differentiable function, which means the derivative exists, what we can do, we will never differentiate a constant. We can take that constant and place in front of the function and focus only on the derivative of the function. That means do not differentiate constant. Constant will stay here. Okay, that means constant and then derivative of the function. Please remember, if we have just the constant, then derivative is 0. Derivative of the constant is 0, but the derivative of the constant times a function is simply constant times derivative of this function. Okay, that means let's see. We do have function 5x squared over 3. And what I see that 5 over 3 is a constant. I can put that constant on the side and just focus on the derivative on the main function. That means derivative of x squared is of course 2x. And now I can combine 10x over 3. And derivative for both of them, derivative of the function, it's actually the same like the derivative of the domain. Domain of the function is the same like the domain of the derivative, and it's all of the numbers. It's just x squared and x. Okay, now another rule, the sum and the difference rule. Derivative of the sum of two differentiable functions is just the sum of two derivatives. Derivative of the difference of two functions, differentiable function, is just the difference of two derivatives. That means I have this slide for you. This is a function, and we can see it's addition, subtraction of all of these power functions times constant. That means we don't have to follow, we don't have to write down everything. I really believe that after practicing, you can give me this answer right away. Right? That means that having the addition and subtraction, of course, we will differentiate term by term. Derivative of the x to the power of 8 plus Please note, 12 is outside, just the derivative of x to the power of 5, minus 4, derivative of x to the power of 4, plus 10, x to the power of 3, minus 6, derivative of x, and plus the derivative of the constant, which of course derivative of constant is 0. Okay, and then derivative of x to the power of 8, of course, is 8x to the power of 7. Copy 12, derivative of x to the power of 5, 5x to the power of 4, and we might multiply 12 times 5, 60. X to the power of 4, 4x cubed, times 4, 16, negative 16. X cubed, 3x squared, multiply by the constant, 10, 30x squared. Derivative of x is 6x, is simply 6, and derivative of x is 1. Or I can say derivative of 6x is 6. Negative 6x, negative 6. And derivative of 5, 0. That's me. I just type all of the rules, but you can give me this right away. It's not necessary to write the rules. To apply the rules, of course, but not put them down. Okay, now I do have one question, and it's a little bit of application. That means, let's see. Find the points on the curve y equals to x to the power of 4 minus 6x squared plus 4, where the tangent line is horizontal. That means we know that horizontal lines has a slope 0. Slope in terms of calculus is the derivative. Slope 0. Okay, that's the concept. Okay, that means let's find the derivative of the function. X to the power of 4 is 4x cubed. Negative 6x squared will be negative 12x and plus 0. One more thing is important. Domain of the function is all of the real numbers. That we don't have any problems. Okay, 4x cubed minus 12x is equal to 0. And now we have to just solve the third degree polynomial equation. Let's factor out 4x, and let's factor out x squared minus 3. And now the 0 product property, x is 0, x is root 3, x is negative root 3. I can take these values, substitute to the original function, and get the corresponding y. That means 4 zeros, square root of 5 minus, square root of 3 minus 5, and negative square root of 3 minus 5. The corresponding y values, one more time, I took from the original function. You can try to substitute and get 4. To get negative 5, to get another negative 5 because it's even function. Okay, that means at these points, function, this polynomial function has a horizontal tangent. And I have the graph for you. It's even function, it's symmetric with respect to the y-axis. We can nicely see this property. Example number 5. Evaluate the limit. Okay, that means now we have the moment that we have to combine a definition, the limit definition of the derivative and the shortcuts, the formulas. That means what I see the limit, and this limit represents the derivative of the function at the number a. And I have to figure out what is the function and what is the number a. That means I see 1 over the quantity x to the power of 10. That means the function is 1 over x to the power of 10. And my number a, it's simply 1. Because let's think maybe the other way. If I will give you a function 1 over x to the power of 10 and the number a, and I will ask you, please find a limit notation. Please find the derivative using the limit definition for this function at point a. That's what we will do. We will say derivative at 1 is limit as h goes to 0 f of a, let me put a for now, a plus h minus f of a over h. Limit as h goes to 0 f of 1 plus h minus f of 1 h. That means the a is 1. I'm just keep changing, but I would like you to show you this. Okay, and now limit sh goes to 0. Function is defined 1 over x to the power of 10. That means this will be 1 over 1 plus 10. And f of 1 will be 1 over 1 to the power of 10. And we can definitely see is the limit from our question, original question. 1 over 1 plus h to the power of 10 minus 1. Okay, I'm just showing you, of course, we don't have to write everything. We do have to realize that this limit represents the derivative of the function 1 over x to the power of 10 at 1. And now, what I can do, I can use the shortcut and get that derivative. That means this function can be rewritten as a power form, x to the power of negative 10. And now I can differentiate this. That means the derivative of this function is negative 10 x to the power of negative 11, because I will be subtracting negative 10 minus 1, it's negative 11. Okay, negative 10 over x to the power of positive 11, and now substituting 1, negative 10 over 1 to the power of 11, which 1 to the power of any number is 1, the answer is negative 10. That we can see the point is the green part. And of course this. We do have to identify a function and a point, use the shortcut, use the power rule in this case, and get the value. And this value represents this limit. Let's look another one. Evaluate the limit of 1 plus h to the power of 100 minus 1 over h. That we can see the value a is 1. That means this is the derivative of the function at 1. But what's the function? X to the power of 100. We can see x to the power of 100. We did evaluate based on the definition. And a is 1. Okay, derivative of this function is 100, x to the power of 99. And if I substitute 1, 100 times 1 to the 99, of course, is 100. That means the answer is 100. Let's do one more. Okay, this one looks like a limit as h goes to 0 for root of the quantity, which I can say right away, my function is the fourth root of x. Fourth root of 81 plus h, 81 is telling me the number, minus 3. That means I'm assuming that this 3 is the value of the function in 81. Fourth root of 81 is 3, because 3 times 3 times 3 times 3 is 81. Okay, that means this limit I know that represents the derivative of the function fourth root of x at 81. Let's use the shortcut and get the answer. I will rewrite this function as x to the power of 1/4. Okay, and now let me use this as value 81. And now I will use the power rule. X to the power of 1/4, the derivative is 1/4, x to the power of 1/4 minus 1. It's 1/4, x to the power of negative 3/4. I can rewrite this as 1/4. Negative means that everything will be placed in the denominator, 4 root of x cubed. Okay, now let's get the derivative at 81. It's 1/4, 4th root of 81, and I can cube everything outside. 4. Okay. 4th root of 81, we know that is 3 and cube. 3 cube is 3 times 3 times 3, 27. Oh, 27 times 4, I believe is 108. You can correct me, but I believe it is 80 and 28. Okay, that means this is my final answer. 108 is the value of the derivative at 81, which the limit represents this. This exercise is really nice. It's really nice connecting a definition and the formulas to see if the students understand this. Okay. Okay, now I do have some application, the physics application, velocity, acceleration. That means, let's see, the equation of the motion of the particle is equal to S equals to 2t cubed minus 5t squared plus 3t plus 4, where S is measured in centimeters and t is time in seconds. Find the acceleration of the function of time. What is the acceleration after 2 seconds? Okay, that means position function. In having position function, and in order to get the velocity, we have to differentiate. Derivative of the position function is the velocity. That means derivative, I can say S prime, possibly, because the function was named S. Derivative of 2t cubed is 6t squared. Derivative of minus 5t squared, negative 10t, and plus 3. Now, the second derivative will give me acceleration. That means second derivative is the acceleration. Derivative of 6t squared, 12t, negative 10t, negative 10, 3, 0. Okay, and then that means this is the position, the acceleration function as a function of time, and then we have to substitute 2. 12 times 2 minus 10, 14 centimeters per second squared. That means again, we did the application, but we didn't, in order to get the derivative, we didn't use the limit notation, we used nice shortcuts, formulas. Okay, now what we have to look, how can we differentiate a product of two functions? That means probably making some guess, even I could call an educational guess. We will probably guess wrong. That's what actually was developed first. And we have to make the correction and get the final answer, of course, corrected. Okay, let's see. Having two functions, product of two functions, f and g, and let's assume that both of them are differentiable. We can differentiate f and g. What we can probably guess, okay, I can have the function, I can maybe name f of x as a x and g of x, x squared. And I can probably think, let's look at this side. That means we do have a product. That means we will guess, okay, I will differentiate x and I will differentiate x squared and multiply together. Derivative of x is 1, derivative of x squared is 2x. Together is 2x. But we can see the question mark. And I can tell you that's not a right answer. Because what we can do, we can check this. In this case, of course, it's obvious that having x times x squared, I can combine them together. They are exact, they are the same type of function. I can combine them. Not always I will be able to combine, because let's imagine a function like x times sine of x, or maybe x times exponential function, e to the x, okay, which will be later. That's not always, but in this case, I can combine and I can simply get x cubed. And we know what's the derivative of x cubed? 3x squared. That means this is the correct answer, which means the conclusion is derivative of the product is not the product of two derivatives. Derivative of the product of two functions is not a product of two derivatives. Okay, that means let's see what we can do. I'm not gonna prove it. I do have a proof, maybe, or maybe I remove that slide, but the proof of the product rule is definitely in your textbook. That means what I will do, I will just give you the final formula. And the formula for the product rule looks like that. Product, derivative of product f times g is equal to derivative of f times the original function g plus function f times derivative of function g, which I can say f prime g plus f g prime. Okay, and now we can try maybe to correct. Or let's use different functions. Oh, okay, that means I didn't remove my slides. I did type the proof. You can probably check, you can pause the video, you can go through. I did start with the product, I used the limit definition, and then I really rewrite and simplify the whole limit and evaluate it, and you can see I got this. F G prime, G F prime. Oh, of course, we can switch the sides. F prime G, F G prime. Okay, that's me. Now let's see, again, a little bit more complicated functions, but still the same type of function. That's me normally having a function 6x cubed times 7x to the power of 4, we will combine together. We will not even think about the product, because that's another my comments, my note. Please always look at the function. If you can combine and if you can avoid a product, just avoid it. Okay, 42x to the power of 7. Derivative will be 42, copy, and times 7x to the power of 6. 42 times 7 is a big number, but we can probably take 1 minute and get the answer. 294x to the power of 6. Simple and easy. But let's look at this one. If I would lie, let's say I will not realize and I will treat this function as my first function, and this is the second. And what I will do, I will apply the product rule. I will do it, I can show you, I type the solution for you, but we will only compare the final answer. You will see that it's the same thing. Okay, that's me derivative of f times g, f times derivative of g. Derivative of x, 6x cubed, 18x squared. Copy this function. Oh, I should remove this. And 6x cubed times derivative of 7x to the power of 4, 28x cubed. Oh, derivative is done. I should remove this. And now multiplying 18 times 7, we can get the answer. 6 times 28, and x to the power of 2 and x to the power of 4 is x to the power of 6, and the same, cube, x cubed times x cubed. And adding together, we got the same answer. I think this is just numerically showing you that the product rule works, but please remember, do not apply all the time. Okay, let's see if we can apply the product rule now, or maybe we can avoid it. If h of x equals to square root of x times g of x times, yes, we can see, we have to remember, and it is known that g at 4 is 8 and g prime at 4 is 7. Find h prime at 4. That's when we do have a function h of x, root x times g of x. And now we see we don't know exactly formula for g of x, that's when we can't combine them together. In order to differentiate, we are forced to use the product rule. Let's see. Derivative of square root of x is 1 over 2 root x. I can, square root of x is x to the power of 1/2. And then applying the product rule, we will have, excuse me, not a product rule, power rule. X to the power of 1/2. Derivative of this is 1/2. X to the power of 1/2 minus 1, negative half. Rewriting without the negative exponent, we're getting this. That's, we can see that's. Okay, that's the product rule. Again, let's come back. Derivative of root x, 1 over 2 root x, plus first function, square root of x, times derivative of the second function, which I have to just write g prime of x. Okay, now they asking for h at 4. Let's substitute instead of x, 4. 4, 4, 4, and 4. And 2 times 2, 4. G at 4 is 8. This was given. And g prime at 4 is 7. Square root of 4, of course, is 2. And I did add everything. It is 2. And as we can see, that's the product rule. Okay, now what we have similar situation for the quotient rule. That means I will not compute based on the some functions. I can definitely tell you that the quotient, the derivative of the quotient is not a quotient of two derivatives. That we do have a formula a little bit similar to the product rule, but let's see. That means this is another rule that we have to really get familiar with. having a quotient of two differentiable function f over g, derivative of this is as follows. F prime g minus fg prime all over original function from the denominator squared, g squared. Okay, that means f over g is again f prime g minus fg prime over g squared. And we have the derivative of the quotient is the denominator times derivative of the numerator minus numerator times derivative of the denominator, all divided by the square of the denominator. Of course, the function from it. Okay. That means let's take this function. Its rational function is definitely a quotient of x squared plus x minus 2 all over x cubed plus 6. And the first thing which I would like to point is similar to the product. If you can avoid a quotient rule, please avoid it. Do not use it. But looking at this function, I can't simplify. I don't really see the common factor. I can't simplify. That means let's use this one. And we can see derivative of the numerator times the function from the denominator minus numerator times derivative of the function from the denominator, all over denominator squared. And then x squared plus x minus 2, that's the derivative, 2x plus 1, copy this function, copy the first function, derivative of x cubed plus 6 is 3x squared, and denominator squared. And I distribute everything. I did apply the negative and simplify a little bit. It's still terrible expression, right? Really complicated. But for the exercise, from the exercise point of view, it's good function because we can definitely, you can try to cover my solution and try to go through the quotient rule and check if you can get the same answer. This will be good exercise. Okay, that means that's what I just said. We don't have to use always, for example, function like that. 3x squared plus 2 root x over x. I see only one term in the denominator. I can definitely simplify a function like that. I can take 3x squared and divide by x. I can take 2 root x and divide by x. And I will get this form, 3x squared over x, of course, is 3x. And I hope we're okay with this one. 2 is fine, that's 2. But what we have root x over x. Root x is x to the power of half, x to the power of 1. If we dividing the same base with different exponents, we subtract the exponents. That means this is my x to the power of negative half. Okay. Okay, and now, no problem. I can just, I didn't differentiate. I can write down for you. Derivative of 3x is just 3. Derivative of x to the negative half, you can see I copy 2. X to the negative half will be negative half, x to the negative half minus 1. 2 times negative half is negative 1. Negative half and negative 1, negative 3 halves. And I can just rewrite as a square root of x cubed. Just to rewrite without the negative exponent. Okay, and this is the final slide of my presentation. That's the summary of all of the formulas. That means derivative of the constant, just 0. That's the power rule, x to the power of n. Constant times a function is just, don't differentiate constant, just differentiate the function. Derivative of the sum is sum of two derivatives. Derivative of the difference of two derivatives. Different rule for the product and quotient. Okay. Fg prime, gf prime, and for the derivative of the quotient looks like that. That means please make sure that you know all of these formulas, check all of the problems that was solved here, and you can practice based on your exercise from the textbook. You can practice these formulas, and then we don't have to spend much time differentiating. Using the definition, we can use these shortcuts. Thank you.